Consumer theory. We're gonna have some cool graphs today. There's this concept of budget constraint, which is what a consumer can afford. Okay, it has to do with your financial state. So it's the possible combinations of different goods that a consumer can buy at a given level of income and prices. So assuming that the price and income is fixed, what are the options that you have? It's very similar to the PPC, the production possibilities curve, very similar to that idea. It's a limit on what you can buy, all right? It's about how far you can go, basically. It's your possible choices in consumption given your income and the prices of the products. So one key term here is can. It's about your ability. It's not how much you actually consume, and it's not how much you want to consume either. It's just your possible choices, okay? So a good way of summarizing it is when we talk about budget, we are talking about the can element, and we are talking about financial ability. In this lesson, we're going to have a bunch of graphs and some math. So follow carefully what's going on and take very good notes. I suggest that you use graph paper if you have. It's going to help a lot. If you don't, then definitely draw your graphs very large and use a ruler, okay, because the numbers are important. So let's just go slowly step by step together. All right, so we're gonna have a grade here, and we're gonna suppose that the two products that we have are movie tickets and drinks. Okay, so a lot of times, we tend to use them together. And let's say your income is $60. You have $60 allocated for movies and drinks. All right, and the price of tickets and the price of drinks is the same at $10. Okay, so we're making the numbers simple. We want to draw your budget line. Okay, so that's the objective here, and in order to draw the budget line, you have to figure out how much you can buy of each product. Okay, if you use all of your income to buy tickets, you can buy 6 units, right? Because what you have is $60, and if you spend that on $10, 60 over 10 is 6, so that's why you get 6 here. Now, if you spend it on drinks, because the price is the same, you can also buy 6 drinks. That's when you buy no tickets at all, right? So the maximum number of drinks you can buy is 6. The maximum number of tickets you can buy is 6. And if you connect those 2 points, you get your budget line. So that's BL. We call it BL1 here. So BL stands for budget line. This, again, is the same in terms of principle. It's the same as the production possibilities curve that you saw in intro. Now, if your income doubles, so from 60 it doubles to 120, right? What's going to happen? If you have twice as much income, assuming that everything else is constant, everything else is equal, so the prices don't change, only your income goes up, then you can afford twice of anything as before. So instead of 6 units of tickets, you can buy 12 units, and instead of 6 drinks, you can buy 12. All right, so you can connect those points and you get a new budget line, which is further out, which means you're more able, you can achieve more things now. All right, so a simple rule, a simple lesson that we find here is that if you have a change of income, then you get a parallel shift of the budget line, and a parallel shift means you have the same slope, but you have different intercepts. So the intercepts, the horizontal and vertical intercepts, are, instead of 6, they're 12, but the slope is the same. All right, so pause here, write down, and draw your graph. Now let's use another diagram here. So you would have to draw another one for yourself, otherwise it's going to be a mess. And we're going to assume that we start with the second scenario in the previous slide, right? So we're going to assume that your income is 120, the price of each product is 10. That's our initial position, right? So we have the second budget line that we just drew. That's our initial state. Now we're going to look at a change in price. So let's say the price of drinks doubles, all right? Everything else constant. That's an extremely important assumption. Remember ceteris paribus? The only change in the universe is that the price of drinks doubles. Everything else is the same. You have the same income, and the price of tickets is the same. All right, so what happens is that you can afford half as many drinks as before. So instead of 12, you can only afford 6 because the price of drinks, instead of 10, it's 20 now, right? So if you divide 120 over 20, you get 6. And you get a new budget line, so budget line 3, where the slope is different. So that's a non-parallel shift. So, and that's called a pivot. Okay, so pivoting is when the line changes slope, right? But this 12 here is the same as before. All right, so that's what happens when there is a change of one price. Pause. Wow, that's cool. All right, so far we talked about the budget. Budget means your ability, all right, how much you can afford. Now we are going to talk about your preference, your indifference curve, which is a curve showing consumption bundles that give the consumer the same level of satisfaction. It's what a consumer wants to consume, not what they're able to consume, but what they would want to consume. It's your relative preference between two goods. So which one would you choose? If you're offered a hamburger and an apple, for instance, right? So if you're really health concerned, you would take the apple, for instance. When you talk about satisfaction, there's a special term in economics for it. It's called utility. Utility means satisfaction or pleasure. And the focus here is want. That's a key term, so you might want to highlight that or underline it. And preference. Okay, so the first things that we talked about the budget line, that was about your budget, your financial ability. Here we are talking about your actual willingness, your liking of something. So for instance, you might say that, okay, you know what, I prefer an apple to an orange and an orange to a banana, or the other way around, or whatever. That idea of your taste, that's reflected by the indifference curve, and we're going to look at the curve a bit later. So this idea of utility, this is a very important term in economics. It's a measure of happiness. Okay, so when we say utility, we are trying to quantify happiness. Marginal utility, this term marginal, you've seen that before. It means how much your utility rises when you have an additional unit of the product. Okay, so one more of some item. And it depends on how much you already have, okay? The first unit of something gives you more utility than the second unit, or the third unit, or the 100th unit. So here's an example. Let's say you're starving, and somebody comes by and offers you a Timbit. You're gonna be pretty happy, right? It gives you a lot of satisfaction because you're starving, right? Now, if you already had food and somebody offers you a Timbit, it's not gonna make you as happy because you already had some food, right? So it really depends on how much you already had. Or think of this, let's say you want to buy a pair of Nike shoes, right? If you get to actually buy your first pair of Nike shoes, then you're going to be pretty happy, right? If you buy a second pair of the same thing, it's not going to add as much to your happiness. So that's called diminishing marginal utility. So the more of a good you consume, an extra unit of it will add less to your utility. Now, one thing to watch out here, diminishing doesn't mean that your happiness goes down. It means that the addition to your happiness goes down. So you still would like to have more, but each additional unit doesn't add as much as before. All right? So pause and write down. All right, we're going to look at the graphical representation of the indifference curve. Here things might get a little bit advanced, but I'm going to walk you through slowly, step by step, so make sure you follow what's being explained and do a new neat diagram for yourself. It's not that hard, it's quite logical actually. We're going to use the same two products as before, tickets and drinks. And let's say we start with a point where you have 4 of each. So imagine yourself, let's say this is your monthly allowance. You have 4 tickets, 4 movie tickets and 4 drinks. Imagine the level of happiness you would have with 4 and 4. Okay, so you have 4 tickets in your hands, in your allowance, and you have 4 drinks. And somebody comes up to you and says, hey, would you trade your tickets for drinks? So would you give me one of your tickets? And I'll give you some drinks. How many drinks should I give you in order to make you as happy? So you want to maintain the same level of satisfaction. If you want to stay as happy as before, let's say for argument's sake that you say, okay, you know what, give me one drink and I'll give you one ticket. Okay, so I'm gonna be just as happy. All right, so what this means is that this second point, point B, gives you the same level of satisfaction, the same level of utility as point A. Now the guy tells you, you know what, give me another ticket. Okay, how many drinks should I give you so that you give me another ticket? You're gonna be like, hang on, this is getting serious now. I mean, I'm gonna have only 2 tickets. Well, you know, I kind of like tickets. I don't want to have, you know, just 2. So if you want to keep me as happy as before, you have to compensate me with 2 more drinks, not just 1. Right? So you're asking for more because you care about tickets and you don't, you know, too many drinks, maybe you don't like that much anyway, right? So you get this point C, which gives you the same level of satisfaction as A and B. Now the guy tells you, you know what, give me another ticket. If you want to give me another ticket, how many drinks should I give you to make you as happy? All right, now you're going to really think about it because you don't want to have only 1 ticket. Yeah, if you want to stay at the same level of happiness, the same level of satisfaction, then maybe you say, you know what, give me 4 more drinks just for 1 ticket. Maybe that's your rate, whatever is your rate. All right, but it's likely that you're going to ask for more because you don't have many tickets left for you anymore. So you get point D, which gives you the same level of satisfaction as C, B, and A. And you can imagine the same thing on the other side. Let's say somebody tells you that, you know what, give me one of your drinks. How many tickets should I give you in order to maintain your level of satisfaction, right? So you could come up with other similar points which look kind of the same, right? And you can connect these points. These are the points that give you the same level of satisfaction. So the points that give you the same level of satisfaction will be on the same line. And this line is called the indifference curve. All right, so IC stands for indifference curve. Okay, so far so good. Now, the reason why this is curvy, this is called convex, right? So it bows inward, it's called convex. It's because if you have a lot of a good, you would be willing to give up more of it to get another unit of what you don't have, right? So usually we like to have, you know, a balance of most things. If you don't have much of something, then we value it more. That's why you get this convex shape. It's not a linear line. It's the same as the diminishing marginal utility. Remember the Timbits example? If you have had a lot of Timbits already, then you don't value it as much. And you would be willing to give up more of it. But if you have only 1, then you won't be willing to give up that 1. All right. Now imagine another point. Let's say you have 6 tickets and 6 drinks. So we call that A prime. If you compare A and A prime, in which case are you happier? I mean, if you have in A prime, you have twice, you have 2 more units of each, right? So it's going to be happier than A. And that's going to correspond to a different line. So you have to draw another line that passes through A prime, and that corresponds to a new indifference curve, which would be a higher level of satisfaction. Okay, so higher indifference curve means higher utility, and higher utility means more satisfaction. Yay! So draw your diagrams. When you do the ICs, make sure you do them curvy. You do them exactly as you see here on the screen. The tails should not curl back up or inward, and they shouldn't intersect. So the ICs never intersect. That's quite an important point. So pause here. If you need to watch again, watch again. It's quite an important part. All right, draw another diagram for yourself for this part. We are gonna look at a budget line. Let's say the intercepts are 9. And we're going to draw 2 indifference curves, IC1 and IC2, right? So here's the question. Remember, higher indifference curve means higher satisfaction, right? So IC2 is preferred to IC1. We would like to be as high as possible. But is it possible to be on IC2? Remember, you can only go as far as your budget line, and your budget line limits you to the green line. So you can't go above the green line. So IC2 is not achievable. It's desirable, but it's not achievable. Okay, IC1 is achievable, but maybe you can do better than that. Maybe you can achieve higher level of satisfaction given your budget. So that's called the consumer's optimal choice. So the optimal choice is to maximize utility given one's budget, right? That's the optimization problem. You want to maximize your satisfaction given the constraint of your budget. So in this case, you can think of a third IC, which is higher than IC1 but lower than IC2, and this is achievable at a single point here where the two lines are barely touching, right? So that's called tangency. So some of you, if you've taken calculus, you know what tangent means. Tangent means when two things are barely touching. Yeah, so barely touching like that. So that's the optimal point, and that's a useful thing to remember. Whenever you want to find the optimal consumption bundle, the optimal consumption bundle of a consumer is when the indifference curve is barely touching the budget line. So in this case, it would be point O on the diagram. Pause. So let's put things together here, and you would want to draw another diagram for yourself, make it wide and neat. Some of you might be like, oh no, this is getting so confusing. Yeah, well, because it's the first time you're getting this material, so it's understandable, but don't freak out. I'm gonna give you a lot of practice, okay? And with practice, you're gonna get it, all right? So if things are a little bit shaky at this point, it's totally fine. You might want to refer back to some of the previous slides to refresh your memory about what's the way to do the budget line and the indifference curve. We're gonna see how to derive the demand curve. So you already know the demand curve shows the relationship between price and quantity. Yeah, where does that come from? It actually comes from indifference curve and the budget line. All right, so let's look at our good old example with tickets and drinks. You have $120 of income for these two items. Let's say that's your monthly allowance, and the price of drinks is 10, so that's fixed. We want to see what happens if the price of tickets rises from 10 to 15 to 30. All right, so what I would suggest that you do right now is to draw 3 budget lines. Okay, you should be able to figure out how to do the budget lines. The budget line is a straight line, and all you need to do is you take your income and you divide it by the price of drinks. So that's going to give you 12. That's going to be your vertical intercept always. So that's going to be easy. The part that you have to calculate is divide your income, 120, divided by the price of tickets. Okay, now if you divide it by the price of tickets, what you get is also 12. So you get your budget line going from 12 to 12, right? Now what I would say is let's pause here and do it also for 15 and for 30. Okay, see what you get. You should get 2 different budget lines based on that. And looking at the first budget line, we also want to find our optimal consumption bundle. And for that, you need to have that curvy thing, you know, the indifference curve. So if you remember, the optimal point is where the two lines are barely touching, right? So in this diagram, it's going to be 0.01. So that's the optimum one, where the consumer is consuming 6 units of each product. Okay. Now, if you divide 120 by 15, what you get is 8, right? That's the new intercept here. And that's your new budget line. That's your budget line 2. And again, we want to find the new optimal point. So you have to draw a new indifference curve. Notice that the indifference curve now is lower because the price is higher, so the person can't afford as many as before. And let's say the point is somewhere there where the lines are barely touching. That's O2. And when the price of tickets rises to $30, then the intercept is going to be 4. So 120 over 30 gives you 4. And again, you have to draw a new indifference curve and find the point where the two lines are barely touching. So that's going to be your new optimum. So if you notice here, what you have is that the quantity consumed of tickets goes down, which makes sense. When the price of something goes up, the quantity goes down, right? Now this graph is kind of confusing. It's kind of like a mess. But if you do a large wide graph, it shouldn't be that bad. And in terms of questions that you get, you get only one shift. All right, so you're gonna have two budget lines and two indifference curve per question. All right, but this should be illustrate to you where we get the demand. So your consumption of tickets drops from 6 units to 4 units to 2 units, right? So at O1 you're consuming 6 units. At O2 you're consuming 4 units. And at O3 you're consuming 2 units, right? Notice that your consumption of drinks doesn't change in this case. All right, it could change, but in this case it doesn't. So we're gonna have a little table with price and quantity. This is a simple demand table. The three prices that we have are 10, 15, and 30. When the price is 10, the quantity consumed of tickets is 6. When the price of tickets is 15, the quantity of tickets you consume is 4. And when the price is 30, the quantity consumed is 2, right? That's the basis for our demand curve. So pause here. If you need to watch it again. Don't rush yourself, and do a nice neat graph and a table for yourself. Almost there. So we have this table that we just derived from the last slide, and we're going to convert that to a graph. Okay, just to remind ourselves, the demand curve shows the relationship between price and quantity. So all we have to do is to plot these points and connect them, right? Now we are here back to our good old price versus quantity, right? So on the vertical axis we have the price of tickets, and here we have the quantity of tickets. Forget about drinks here. The first point that we have is where the price is 10 and the quantity is 6. So you have to find that point. So it's going to be 6 and 10. So the point of their intersection is going to be somewhere around there. And the second point is going to be 15 and 4. So when the price is 15 and the quantity is 4, and the last point is when the price is 30 and the quantity is 2. All right, so that's going to be our third point. And all you do is you just connect them, and that's going to be your demand curve. Okay, so that's the demand for tickets. So that's basically where the demand comes from. It's the optimal consumption quantity of a buyer at various prices. All right, so pause here and draw a nice neat demand curve for yourself. Here's a cool paradox in economics. Why are essential products like water so cheap while unnecessary ones like diamond are so expensive? Okay, Adam Smith discussed this, and before him John Locke and others addressed it. It's at the core of modern economics. There are a few explanations for this. It's not really a paradox if you think of it. One of them is the difference between total value versus marginal value. If you remember, marginal value means the value of that one last item, as opposed to total value should be the value of all of them, right? So the value that the society places on water overall is a lot more than the value that it places on diamonds. The amount of money that's spent on water is a lot more, okay? But the thing is, there's also a lot more supply of water as opposed to diamonds, which is scarce. And because of scarcity, the price would go up. Okay, just think of it like this. If you are in a situation where you are really thirsty, which one would you choose? You would give up your diamond, you would give up all of your gold and diamond and all that to get water. Okay, so it is actually, but you won't do vice versa. You won't go the other way around, because you need water but you don't need diamond. And that brings us to this idea of exchange value versus use value. The reason why people would like diamond is not because of its use, but because of the ability to exchange it for something else, right? So if you're in a position that you can exchange and get something else, yeah, you would go with the diamond. But if you really want to use something, then water has a higher use value than exchange value, right? So really, there's no paradox. Water is overall more valuable than diamond, but not every additional unit of it, okay, it's also more abundant. Okay, so because of that abundance, then the value may seem to be lower, but that's only the marginal value, not the total value. There is something called the Giffen good. You might see it elsewhere. Giffen good is kind of like a bizarre good. It's an exception where the demand curve would slope upward. Now, upward sloping demand curve means a positive correlation. Yeah. So if the price goes up, then the quantity demanded would also go up, and that is against the law of demand. So this was brought up by Sir Robert Giffen, where he observed that the bread in England had this tendency, and also there was a case of potatoes in the Irish famine of the 19th century. Also, there are some studies in China on poor households and their consumption of rice. Now, this can be, theoretically, it is possible, but it's extremely exceptional. It can be the case of staples for poor individuals, okay, where they spend a large portion of their income on that item, okay. But it's unknown in the modern world, okay. We don't really have clear examples of it. What you have to be very sensitive about in all of these things is the ceteris paribus assumption. Remember, the law of demand doesn't say that whenever the price goes up, quantity goes down. It says if the price goes up, other things being equal. Okay, that's an important assumption. A lot of times something may seem like a given good, but it's not respecting the ceteris paribus assumption, and you have to be very careful about that. Something that's actually cool is this idea of conspicuous consumption, and that was brought up by a brilliant economist called Thorstein Veblen at the end of the 19th century. The idea is that purchasing a product not for its intrinsic qualities, but because it confers status, or because of the snob appeal. In other words, you can show off, right? So the idea is that there are certain products that people buy in order to show off. And what that means is that the actual price is desirable. Not that the price is a hurdle, but the price is desirable because the price gives you this status, okay? Now, this may also sound like contravening the law of demand, because if the price is higher, then people would desire it more. But that again doesn't respect the ceteris paribus assumption, because what it says is that if the price is going up, other things being equal. But if the price also goes up and at the same time there's more status, then you're not observing the ceteris paribus assumption. Okay, so the idea is that yeah, you just want to be the best and you want to show off. Holding this status constant, people would buy more at a lower price, right? So now when you say holding the status constant, means assuming that that item, that luxury item, gives you the same level of status, so that is respecting the ceteris paribus assumption, then people buy more at a lower price, which is respecting the law of demand, right? So there's no problem there. So this would be the case of all the luxury items, all the luxury cars, luxury brands, like your Gucci bag or cosmetics or your Bentley car or whatever, right? So all of these things can be examples of conspicuous consumption. Conspicuous means you just want to show off, all right? So pause here and take notes. If you remember, we talked about substitutes and complements. There are some extreme cases where you have perfect substitutes, where there's absolutely no difference between the two options. So think of dimes and nickels. One dime equals 2 nickels, and they're just equal in value, right? So there is a fixed exchange rate between them. The indifference curve for them would be a straight line. Okay, it's not gonna bow inward, right? So the shapes of that would be just straight lines like this. So 1 dime would equal 2 nickels, 2 dimes would equal 4 nickels, and so forth, right? I here refers to IC. It's the same as the IC that you saw. I'm just showing you different notations so that if you see them, you don't feel confused. The other one is perfect complements. Perfect complements mean things that if you have one item, then you need one of the other item to work, right? So for a person who has 2 feet, they need one right shoe and on the left shoe, right? If you have 1 pair of shoes, it's better for you, it's more useful to you than if you have 10 right shoes only, right? I mean, you're like, oh no, what can I do with this just right shoe? No, it's not useful, right? In that case, there's going to be a right angle indifference curve. It's going to be kinked, as you see in this diagram. So if you see here, if you have 5 right shoes and 5 left shoes, it gives you a certain level of satisfaction, like here. And if you have more left shoes or more right shoes, it's going to be the same level of satisfaction, because just having one side is not gonna give you any more satisfaction. All right, so pause here and draw your diagrams.